Hello. Today we are going to solve LeetCode 3661 maximum walls destroyed by robots. It's a hard problem. Let's see what it says. Basically, there is an endless straight line populated with some robots and walls. You are given integer arrays, robots, distance, and walls. Robot I is the position of the ith robot, distance I is the maximum distance the ith robot bullet can travel, walls j is the position of the jth wall. Every robot has one bullet that can either fire to the left or right at most distance 5 meters. A bullet can destroy every walls in its path that lies within its range. Robots are fixed obstacles. If a bullet hits another robot before reaching a wall, it immediately stops at the robot and cannot continue. Return the maximum number of unique walls that can be destroyed by the robots. Okay. But if the nodes, a wall and a robot may share the same position, the wall can be destroyed by the robot at the position, and robot are not destroyed by bullets. Okay. So what is said in this problem that there are some robot and walls in a like straight line, infinite line. Every robot has one bullet that can travel to some distance. The robot can fire it either to the left or right. The bullet will destroy every walls. It will uh, get in the path and will stop either like when its distance will covered up or another robot like appear. Why we have to find like how many unique wall we can destroy, maximum of wall we can destroy with this setup. Okay. So what will be our idea? So let's consider there are some robots here in the path, and there are some walls. Some wall might even come at the same position of the robot. Okay. So here, what we are going to do, it is basically a dynamic programming problem because every robot has two choice. It can either fire the bullet to the left or right, so we don't know like uh, firing in which direction is optimal. So we will calculate every possibilities that it can happen. So we will consider a DP. Uh, so DP of I for the ith robot, DP of I comma like there is it will be a state. This state will be either L or R. Means the ith robot is firing bullet towards left or right, and it will calculate the maximum. Uh, let's put a text here. Basically, it will calculate maximum number of walls that can be destroyed. Um, Sorry for the handwriting here. That can be destroyed. What is the idea? Basically, we will form a DP of I, and then L or R that will signify the in which direction the ith robot is firing, and maximum number of walls that can be destroyed. Okay. And we will consider like the while calculating for the ith robot, we will consider that there are no more robots to the right side or something. So for this, like if this robot firing to the left side, so what will be the number of walls? It will be from here to like uh, the R0 is the position of robot minus D0. Basically, the distance bullet can travel. So this is R0 position, and this will be the R0 minus D0, like up to where the bullet can travel. So the number of balls in it, this if the robot fires in the left side. Okay. And similarly, if this robot fires to the right side, so then it will calculate the number of bullets from like it will calculate like R0, then from R0 to R0 plus D0, R0 plus D0. But this R0 plus D0 can like uh, overtake the next robot. No? So basically, the bullet can't uh, like overtake any robot or like can go beyond any robot. So we will take basically minimum of this point comma next robot position, that is I plus 1. So that will be the idea of us. And for like robot in the middle, what we will do, like for this robot, if this robot is firing to the towards right, so then we will just calculate number of walls here, and we'll add up to the previous robot answer, like the optimal answer for previous robot if it's fired towards left or right. And if this robot is like firing towards right, then there will be two possibilities, like it is firing, like there was four possibilities, like either it is firing towards right and then it is firing towards right or left. But as the zones are different, because bullet won't interact with each other, so it will be very clear, like this plus based of this or this. And if this robot is firing towards left, then one way will be the number of balls for this and the number of balls for this, like previous robot is firing towards left. And another thing may happen, like both robots firing towards the same side. So then we have to just calculate the range, like uh, towards how much this bullet will go. For that, what we will do, we will consider like this is Ri, and this position, how much position it will go. Like it may go beyond this robot, or here and here. Like there are three possibilities. Let's consider this robot travels up to this bullet travels up to this point. So this bullet can go either beyond to the robot, which is not possible. So either here or here. Like this bullet won't cross each other, or they might cross. But we have to find the number of unique walls. So let's consider they won't cross. Like if they cross, we will bound them up to this point. So this range will be like Ri minus Di, which is this bullets is going to traverse, and maximum of this point and the previous bullet up to this up to that which point it traverses. So it will be Ri minus 1, the previous robot, plus the distance its bullet travels. So this is our concept, like we are going to do this. So let's go to the editor here. So first we will find the number of robot. Let's rename this as R distance T and then one size W. So we don't have to type that one. So R dot size. Mm, and we will sort the value. Is the value like R value sorted? No, nothing. So we will sort. First, we will sort robot and distance robot, but we have to also arrange the distance according to the robot. So let's make a function custom sort which will sort our robot and distance in their order, and then we will simply sort the world. And another thing is that uh, some wall might like locate at the position of the robot. So we will simply remove them first, because like while calculating the range we have to be careful about those walls. So for the clarification of the operation we will consider that no walls and robot are at the same position. So because if a wall is located in the position of a robot, in anyhow like the robot is either firing to the left or right, doesn't matter, the wall will be destroyed. So we won't we will simply remove and count them uh, for the clarification of the operation. So where sort, we have already sorted them. Now what we are going to do, we will just remove robot and walls if they are in the same position, and return the number of them. So what does it do? It basically removes the wall that are in the same position as of they that are in the same position within robot, and return the number of such walls. Okay. What does this sort do? Basically, sort the robot in non-decreasing order and arrange the respective distances according to the robot. Basically, if we are sorting the robot and changing their like order, we have to change their respective distance also in the same order. So there we go. Now what we will do, let's add infinity. Basically, let's put another robot at the infinite place, so that whenever we will be in the last robot and we will query for the next robot, there uh, should be like either we can check for a bound, or we can simply add a robot in the infinity so that we don't have to check that. So infinity, let's declare infinity here. 29, I think 29 should be good. What is the constant? 1 million. Now what we are going to do, let's keep the number of, or it should be in the top, doesn't matter. Now what we do, we will we have to declare a DP, vector DP in comma vector 2 comma 0. So here the basically DP of I comma 0 is number of walls we can destroy if ith robot fire towards left and fire towards left, and similarly dp of I0 simply sorry I1 number of walls we can destroy if the ith robot fires toward right. So now let's write the simple base case. It's like dp of 0 comma 0. What will be dp of 0 0 uh, if the first robot fire towards left? So it will be simply just count of mm, like count. We will count what we will count. Let's write a function count. So count L comma R comma L comma R. What will return? It will simply return the number of walls in the range L comma R. Okay. So count LR will return the number of walls in the range LR. So dp of 0 0 will be simply like R0 minus D0 comma R0. So this will be this. Now dp of 0 comma 1 equal to simply count of what will be the range? Range will be R0 comma R0 plus D0, but the next robot might appear there. So for that we will do R1 max of sorry minimum of both. Okay. Now we will simply cover the other robot, and like if current robot is firing towards left, so the previous robot can fire towards left or right. So now let's consider current robot is firing towards left. So there are two cases. Two cases. One is that the previous robot is also firing towards left, and another case will be the previous robot is firing towards right. So in the first case, in answer 1, what will be answer here? Answer will be simply like current robot is firing towards left and previous robot is also firing towards left. So the number will be previous robot is firing towards left, so dp of I minus 1 comma 0 plus we will just count from like Ri minus di maximum of comma Ri minus 1 comma Ri. So what we have done here, so basically in this case, like let's clear this. So in this case, the both robots are firing towards left. So dp of this I minus 1 comma 0 will calculate this. Like we already stored the answer here, and uh, now we have to count the only how many walls are in this range from Ri to Ri minus di, maximum of Ri minus di, comma Ri minus 1 comma di minus 1. So this is maximum of Ri minus di, comma Ri minus 1 and Ri. Okay. And for here, answer 2, what we will do dp of I minus 1 on comma 1 will store like has already stored the answer, and we will count the maximum of, or if both are firing towards like the same direction here. So as we have used the dp here, so we already calculate the bullet like up to this, how many walls are there. So we have to restrict the bullet up to this point. So we will do what we will do dp of I1 comma count of maximum of like r minus 1 comma plus d minus 1. The previous bullet has traversed up to d plus 1, like we don't want to calculate the point twice, and ri minus di and ri. I think that's good. Now dp of I comma 0 will be simply max of these two answers, answer 1 comma answer 2. And for dp of I comma 1, like uh, current robot current robot is firing towards right. Then the case is simple, like we'll simply take the optimal answer for previous dp, like dp of I minus 1 comma 0 comma dp of I minus 1 comma 1 plus we will just count the number of walls in ri comma ri plus di, and lastly we will simply return the same, means how many walls were there at the same position of the robot, which is the same, and plus maximum of dp of n minus 1 comma 0 comma dp of n minus 1 comma 1. That's all. Now we have to write the functions here. First, let's take this custom sort. We'll take two vectors. So void custom sort. It will take two vector in like robot and vector in distance. Okay. And now what we'll do, we will take the size here, that size. Uh, Now we can um, consider, we can take another vector, prepare intent bpn. Okay. Now let's put the value here. Dp of I equal to make pair ri comma di. Now sort this thing and reload the value in their respective fields. Ri equal to vp of I dot first and di equal to vp of I dot second. I think that's cool. Like what we have taken the size. Now we have a pair of vector. Now for this we have just loaded this and sort. After sorting this, we have also reloaded. Oh, that's correct, I think. Now we have to write remove function, which will remove the walls that are in the same position within robot and return the number of such walls away. So in remove function will be there, which will take two vectors Let's copy this to vector. We'll take robot and wall. Okay, and here robot should be constant. And what we'll do in count 0, we'll take a count and we will take a set and we will load the value of the robot here. Also, we will take a copy of the uh, copy of W and simply go over the all values of W. If basically set dot contain this value, then we will increase the count. Otherwise we will load it in the copy W dot is the get, and after that we will update the W and simply return the count. So what we have done, we have basically loaded the position of the robot in a set, and then for the walls we will detecting if like any robot are already in the same position, then we will just simply update the count. Otherwise we will take that wall in a copy vector and then update this wall with a copy one. Okay, and the last function we have to write the count function. So count of LR, what does it do? Count of LR return the number of walls in the range LR. Okay, so there should be count vector in count. It will take L comma int R and a vector constant vector in W. Okay, so how to count, like this wall is sorted, right? So how to count like how many value in this vector are in between L and R? For that we can use binary search, like how many element are less than R and how many element are less than like L, and simply subtract that their name to find out this, like what is going on here. Like let's consider here 1 2 3 5 7 and 10 and 11 are in the vector, and our L is suppose 2 and R is 10. So what we'll do, we'll binary search like how many element are less than 10. So it will return these element are less than or equal to 10, and then we will binary search how many element are strictly less than 2. So it will give us this, and if we subtract we will get the element which are in this range. Okay, so basically we'll do upper bound. You can also use lower bound. Upper bound will return like how many element are less than or equal to. So for that R minus upper bound wall comma L minus 1, like return. So what I have done, we have count like how many values are less or equal to R and how many values are less than equal to L minus 1, and just simply subtract them and return. So this should work. Let's test it on the sample. What says too many few? Okay, we have not passed walls in this count function. So let's do the here is a count and here is a count. Now run this. Okay, here is capital W. Let's replace these terms with capital W. Now paste this on the samples. What does it say? Okay, we have to put here the minimum parenthesis should be here. Now undeclared identifier W in HP. Capital W, or we can simply replace with capital W and skip this. And here it right passed on the samples. Let's paste in H3 all the cases. Got a wrong answer here. So what is happening? What we are doing here? We are custom sorted these, now sorted the walls, and this infinity. Now we have D3. DP of 0 0 each, R0 minus D0 comma R0. Yeah, 0 1 is R0 minimum, R0 plus D0 comma R1. That looks fine. Now for this, answer 1 is basically answer 1 is maximum of Ri minus Di. Previous robot is also firing towards left, so its left value and Ri minus Di comma Ri minus 1 comma Ri. Yeah, that's fine. And for here, this is also calculating its right value and doing Ri minus 1 plus Di minus 1 plus 1 and Ri minus Di. We're taking maximum of both of these. And here, okay. And now, if the current robot is firing towards right, then max of this and count. Oh, count Ri comma. Here we have to take minimum of Ri comma Di comma R of I plus 1. So basically we have to restrict the bullet up to the next robot. Let's use this test case also and run on the samples. Like it should pass. So yeah. Now let's submit this. Yeah, it got AC. So basically, what is the time complexity of this? Like this custom sort is taking in log n time. This is also taking in log n time. Here this remove function also, we can make it linear, but it is also taking in log n time. This DP is basically n cross 2, so it is linear. And here we are going linear, and this is constant, and this is log n time. This is also logarithmic time. So that means like we are in cross log n. So this whole loop is also in log n time, and this. So basically we are using a couple of functions or operations which are in log n time complexity. So the overall complexity of this code is in log n. So that's all for today. Thank you.